All right. Can you see my screen well?
I can see it.
Perfect. You will think that the 2 years of doing things online, I will get a good handle of Zoom. Every time, it's like, do you see me? Do you hear me?
I think we all do that.
Yeah. So thank you so much for inviting me to give a talk here. I'm so excited. Actually, one of my first introductions to R was through Our Ladies. I just don't remember which Our Ladies. It was one international. And I was learning a little bit more about wrangling data and how using Tidyverse. I was like, okay, this is amazing. So I want to teach, I want to show everyone the cool things you can do with just basic functions. And it's been great. Let's see if I can move my slides. I just want to thank to Dave Kite, Danny Navarro, and Paul Campbell for their content. I've been following them for years now. They've been so great, like sharing their content and resources online. So feel free to follow them and find out what else they've done so far. They do wonderful things. So the plan for today will be I'm going to go over a little bit of logistics, a very quick introduction to our markdowns, because I just realized that my exercises that I have for you to do are using our markdown, that I wasn't sure how much our markdown experience you had. So I'm going to give you a very quick intro on how our markdown files look like and how you can like complete them and what are the different parts of an RMD file. I'm going to go over a little bit of our data set so you are familiar with what we're going to be using throughout the talk, and the examples that I'm going to be showing you are going to be using that same data set. And then we're going to go deep into data wrangling. I'm going to walk you through some exercises and functions I'm going to be using that I normally use on a regular basis. And then a couple of tips and resources I have at the end for all of you. So a couple logistics, like Crystal mentioned, feel free to download the materials. You are more than welcome to just go ahead and download the zip file or use GitHub to get in your desktop, and then just follow me using the materials and doing the exercises along with me. Or you can just sit and listen to what I'm going to be walking you through, and that's completely fine. So our markdown, what is it? I think our markdown is very, very cool. And you're going to be seeing throughout my whole talk, I use a lot of Alison Hort's images are amazing, and it just make it so much easier to understand what the different functions are doing, what different packages are doing. So it's just great. So our markdown allows you to create content like PDFs with actual text and code integrated into one document. So you don't need to have an R script separately with your code and then a Word document with your content. So you can merge them together and you can export them in formats that will actually be helpful for you to share with other people, like PDF, HTML, and like Word doc. So usually when you open a markdown document in R, you do it like you create an R script. You just go to open files, select the R markdown option, and then you get a template that looks something like this. And it has a couple sections. In the document at the very top, there's the YAML section. I'm going to walk you through each of them so you see what's going on in each of them. There's some code chunks. We call them code chunks, where you are going to insert your code that you want to run in your script. I'm going to go over a little bit more later. And then you have actual text, and then you can just write a whole description of what you're doing in there, and it will export it as a regular text without giving you any errors. Like usually you write comments with a hashtag in our markdown. You don't have to do the hashtags in the text section. You just write it like a normal text document. And whenever you're ready to export it or need it, which is how we call it when we export it or render it, we click the button Neat, and then at the end, it creates a document. In here, we specified it's a Word doc, so it's created a Word document of my data set or of my analysis at that time, which is doing a graph. So the very top of that document, of an RMD document, there is a YAML section. It stands for YAML in markup language. I still don't understand what that means. I just know that that's what it means. And this section is where you can add the title, the author, you can add dates, different output options, and then you can play a little more with this, but you can create automatized table of content, and you can specify how many levels you want your table of content to go. So you can do very cool things for a general document in the YAML section. Then in the text section, we use Markdown to create some cool stylistic changes. So for example, if I want some of my words in sentences to be bolded or italicized, I can use the double asterisk, and that will make those words in between those double asterisks to have the bold format. And if I only have one, the text in between those one asterisk is gonna be italicized. You can also specify headers in an RMD document to make things a lot easier to follow by creating the hashtag. The hashtag, each hashtag specifies the level of your header. So if you put 2 hashtags, you're saying that you want a second level header, 3 hashtags, a third level header. And when you render it, you're going to see something like this on the right. You can also specify lists, which is very cool. You can simply have bulleted lists and just have them all listed as with bullet points, or you can number them. And you can just do 1 point or 2 point, whatever number, doesn't matter, as long as there's number and a period and space. And then it will automatically give you the numbered list, which is very cool because sometimes you have many rows of many items in your list that you want to list in your document and you just forget to keep track. Your RMD document will know what to do with it. It doesn't matter if you say 1, 2, 2, 2, 2, it will still give you 1, 2, 3, 4, 5 in the actual order because it recognizes it's a numeric and you want a number list. So I just keep it 1 by 1. The important chunks are the code chunks, and they start with 3 backticks and an R, and they end with a 3 backticks, as you can see them here. So in between those things, you create a code that you want to run in your script. In this case, I'm creating a ggplot image that it will run when I render it, and it will be part of my document. The cool thing of these code chunks is that you not only have to use R, so if you're familiar with Python or SQL or other languages, you can also include them as part of your R&D document, and which makes it so much easier when you're learning something and you're coming from another language, because then you can code switch. You can use a chunk that uses R and then a chunk that uses Python, which is very, very helpful when you're transferring from another language or integrating teammates from other languages, which I really, really like. So if I render my document, I can have a ggplot like this one that will export in my document. But if I don't specify it, it will just show the image in itself, or I can specify and actually show the code, which is very cool when I'm sharing my code with other people, because then they can see my code and the actual output out of this, and then they can help me out. You can insert this code chunk by going to the top, clicking insert, and then selecting the code chunk that you want to use. So in this case, I want to do R, but there are many options in there, as you can see, and it will show up. You can also use keyboard shortcuts for this. So if you're using a Windows computer, you can use Control-Alt-I. And if you're using a Mac, you can do it with Command-Option-I. And it will insert your code chunk in there. It makes it so much easier. In each of these code chunks, you can specify certain things. You can specify that every time you render, you want the document to also render the warning that show up in that code chunk. or the messages. You can specify even the width and the height of specific figures that you create in those code chunks directly in those options. Or you can tell it not to show anything, or even not to run specific code chunks. So it's very helpful because they're very independent in each of the code chunks in your R&D. There's also a very cool thing that there's a special code chunk at the beginning of your document that you can create that will overrun all of your R&D document. It will set it for all the code chunks that you create in that document. Right from the beginning, you can set it and be like, I don't want any of the code chunks from now on in this document to show me warnings every time I render it. And you can specify in this specific a special code chunk at the beginning of your document that will just set it for the rest of your writing code and R&D, which is very helpful. You don't have to think about it. But it doesn't mean that you're set with these rules only. And like if you change your mind in specific code chunks later on, for example, this will do it for a global level. But if there's one individual chunk that I would really like to show my code, I would like people to see the behind the scenes of my code, of my figure, I could overrule this and specify in that specific code chunk that I want to show my code. And whenever I render it, that's what it's going to hide it for all the other code chunks, but that specific one that I specify I want to show my code, it will show. So it's very cool, and you can play around with this. It's just not very important for what I'm going to walk you through, but it's very cool things that you can play around and see what different things do in your documents or in the exercises that I gave you in the GitHub. Okay, so our data set, let's go very quickly. I'm going to be using the Child Health and Developmental Studies data set. So in this one, it's a data set that was collected in 1961 and 1962. It collects the birth weight of the kids, the day that they were born, gestational period. They collect information about the baby's parents, so the age, education, height, weight, also smoking practices from the mom's perspective. You can find the actual data set on this website, and there's an R package with information on what each of the columns are. But you also have access to this data set already in the GitHub material section in the folder called data. Or data set. Oh, it's called data. So I also included in that same folder, in the data folder, I included the dictionary of the data set that we're going to be using, just to make it easier for you to understand what we're actually, what is each column referring to. So there are sections like WT, it means it's birth weight. WT period 1 is mom's weight. So it's very, very helpful for everyone. Honestly, it doesn't matter if you write it in Word doc, if you make an Excel dictionary, if you make it in PDF, or if you write it down handwritten in a piece of paper and you put a picture of that in your folder. Honestly, at the end of the day, it doesn't know. That's way better than having a data set with random names of columns and not knowing what they refer to. So I've had situations where people have given me data sets and I ask them like, what does X2 refer to? And I'm like, I don't know, it was there before I got here. What can I do with it? Or very not helpful names. It happens. Sometimes you get those, or sometimes you do those because you're tired and you're like, I just want to go over very quickly. So very good practice to always create dictionaries for yourself and for other people about what each of your columns are doing and more information about what the codes are. So there is one, like, for example, education level. In the data set, and I'm going to walk you through the data set, it's all numbers. So they have education, in the education column, you have 0, 1, 2, 3. So in the dictionary here, we know that 0 means less than 8th grade. We know that a 1 in education column means that the parent had a maximum education of 8th to 12th grade. So that's very helpful, and I beg you to please incorporate it in your own like coding experience, because it's gonna save your future self so much more time. Let's see. I'm a big fan of Tidyverse. I really am. I think they did a wonderful job introducing all of us to Tidyverse. What it is it's a package that collects many package fields. Like inside of, once you load Tidyverse, you automatically load tidyr, string r, dplyr, forecast, all at the same time, which is very helpful. And all of these packages can help you clean your data. They're very easy to follow, and there's many resources out there, people showing you examples, which I really appreciate. One key thing with Tidyverse is that we use this thing called the pipe, and it's this symbol over here with the %, more than, and then %. For us to move different steps of our code. And the way I read this, I use it as if I were using the word then. So for example, in this code over here, I will read this pipe as if we're like this. I'm gonna load my data, then I'm gonna filter all the rows that have age below 25. Then I'm gonna do something. I'm gonna summarize this data by grouping them first on this specific column called education. And then I'm gonna summarize them and create a mean column for gestation. So I'm telling you step by step, kind of like a recipe of what I wanna do on my code. So anytime you see the spots, it's easier to think of them like if you say, okay, I'm gonna do this, and then I'm gonna do these other things, then I'm gonna do this other thing. This is another art by Alison Horst that I really like. You can insert the pipe by using Ctrl-Shift-M in Windows. You can do it by inserting in Mac Command-Shift-M. No matter how much I try, I cannot remember this shortcut. I have a post-it note every time. It's fine. I've been using this for years. I still cannot remember the shortcut. But there it is. You can use it. So today I'm going to walk you through around 12 different functions. I'm maybe overachieving, but I'm hoping I can make it. Where I'm going to show you a little bit about how you can rename and clean your names, which is very important when you're cleaning your data set, to make the names of your columns to be consistent. So I'm going to show you how you can make all your title or your column names to be uppercase, lowercase, clean, consistent, and how you can rename them. Also, I'm going to show you a little bit about how you can separate and unite certain columns. That was just an extra thing that I just ended up using it like a couple weeks ago, and I figured it would be cool to share with you all. And then some basic, very necessary functions like select, filter, how you can mutate or modify specific cells in your data set. Sometimes it's necessary to recode. So I'm going to show you and walk you through how to use mutate and case when you're using this, and then how you can use it, how you can use summarize, how you can calculate means, the standard deviations, calculate the minimum, the maximum number of your specific range. And then at the end, I'm going to show you very quickly how you can move columns in your data set, because sometimes you have to share this data set with, after you clean it, you make it pretty, you may be the one doing the graphing, or you may have to share it with someone else, and you have to re-export it as a CSV. But the columns are not really like where you want them to be. instead of doing that manual movement of those columns, I'm going to show you very quickly how in Relocate you can do that. And then we're going to end with how you can pivot your data set from having it wide and moving it into a longer format, or having it longer and then moving it into a wide format, which could be very helpful for certain things. Okay, so let's do this. Let me get out of these slides. And then I can load. So once you downloaded your GitHub materials, you're normally going to get, if you do with zip or whatever, you're going to get all of this information. You normally want to open the project. And whenever you open the project, you want to direct it here in your files section to open the specific file. Oh, it's loading. I'm going to close everything. So this is the project that we're going to be working from. Right now, I'm going to show you some examples. There's some exercises that you can do in your own time. And I also gave you the solution so you can actually know how to fix this. But if we have time, we also have a big exercise at the end if you want to do that. All right. So this is the example section, and I can walk you through each of them, and then we can see if time allows for exercises. So first, before you use any of your functions, you want to install them. So at this time, hopefully you have it installed already. If you haven't, you can do it through code, or you can simply go to packages, click install, and then find the package that you want. In this case, you want Tidyverse. So you can just find it here. It's taking forever to load for me, but then you click install and you will have it installed on your computer. You only have to install it once on your computer, but you always have to load it, which is the library here, every session you start an R. Otherwise, it won't recognize what function you're telling it to do. So let's load my library Tidyverse so I can load the package. You can do it with command return. And since this is an RMD document, I can just run that code chunk and it will do all the coding here. Perfect. We have the package loaded already. Or I think it is loading. Of course, when I need to teach, things are slow. Okay, still loading. Okay, perfect. It is loaded. And now we're going to import our data set. So you see here, we're telling you that our data set that is called all of these, it's in the folder called data. And you have access to that too. So let's load this data set. I'm saying here that I want to call it data. From now on, I'm going to refer to this data set as data. And you see that it was loaded because it shows up here in my environment. So let's check out my data set. So head will allow me to see the first 15 rows of my data set. So I can take a quick peek on how it looks like. So you see here, we have an ID column, a plurality column, and dictionary will tell you what exactly that is. I think that one was honestly, I don't know. I thought it was the number of kids, but I will have to go back to the dictionary to know what that means. But then we also have the date of visit, the station length, the sex, the weight of the child announces, parity, race of the child, age of the mom, the education level of the mom. We also have information about the dad, and the dad information starts with a D. So DH is the dad age, DED, it's the dad education. We also have marital status for the mom, the income level, the smoke habit, and a couple more information here that I don't remember on top of my head that are in the dictionary. We just don't use them in my examples, so I forgot. But we have a very quick intro of how our data set looks like. I like to specify 15. I have no idea why, that's preference, but if you just do head data, it will give you the default is that it's going to show you the first 6 rows of your data set. But you can specify by putting a comma and a number, and you can do whatever number you want. And it will show you that. Of course, the more numbers you give it, it takes longer. You can also ask it to give you the last row, not the beginning row. So you can do tell data 12. What it's going to give me is the last 12 rows of my data set. It's a very cool thing if you just want to see how it looks like very quickly and make sure everything is looking all right. You will know very quickly if things are switched. Okay, so now we have our data set all added into our R&D and our environment, so we're ready to do some data wrangling. So first, I wanted to show you very quickly how you can rename some of your column names. So you can clean the columns with that have too many characters, or it just doesn't make sense. Some of them just don't do it. So in this case, I'm just going to show you how to shorten one of them. So instead of calling the column date of visit, as you can remember here, we have a column called date of visit. I find it too long. And sometimes you find even longer ones. So I'm going to change it to, instead of date of visit, I'm just going to use date. So what I'm going to use, I'm going to use the function rename over here. And then I'm going to call my data set. So this is where you put the name of the data set. So if on my data set I call it DF, then I'm going to use DF here. And then in this section, first you give it the name that you want that column to be renamed to. And then you give it the old name of that column. So if I run that, and you see that I'm telling it to override my previous data frame called data. And if I run my head function again, you see here that now that column is called date. It was way easier than me having to do it manually and then loading this data set again and then figuring out that I forgot to label it again. So you can have it already in your code. You can also make all of your names of your columns to be uppercase or lowercase by specifying here using the function rename with, which is, if you do a question mark and then the function, it will give you more information about it. So let's find out a little bit more about it. So in my console, I'm asking it to give me info about rename. So it's part of the package called deployer. And in here, you can find more information about the description, more details on how to use it, what each of these sections are, and some cool examples here that I found it very cool when they incorporate the running examples right away, because now I know what they're actually doing. Very helpful. I don't know if you all knew, but it took me forever to find out that there is a tutorial section in here that I thought was very cool. On the very top, you can go to tutorials, and there is some like quick tutorials that you can watch while you're learning. It's very handy. But okay, so coming back to rename with, so I'm gonna call my data frame. I'm gonna tell it to make all the names of my columns uppercase. So you're gonna see here, once I load it, that all my columns are uppercase, which is very cool because sometimes you get some columns uppercase, some columns lowercase, and then while you're calling them, it's a lot easier for you to make mistakes or for you to get errors because you keep calling the wrong column. And using the same format, you can just say to lower, and it will make the columns all lowercase. Very easy to just keep it. It's highly recommended for you to be consistent. It doesn't matter what format you end up using, it's just that you're consistent at using that format. So choose one form and stick with it. And it's going to make your life and everyone else that uses this code, their life so much easier. So highly recommend that. Another package that is not necessarily part of the Tidyverse world is, or universe, that's Tidyverse. It's Janitor. I found it very cool because you can use a function called clean name. And this function will help you specify the specific format that you would like your columns names to have. So the big camel will make, because I didn't load my Janitor package. Yeah, see the error. Now, if I refer to big camel, each first letter of a word will be uppercase. So that was very cool for some people. If I wanted all uppercase, I could call it the screaming snake, and it will make all of them uppercase. Who labeled them? I'm not entirely sure. But if you want all the formats, you can just do the same as we did before. Go to the console. We can just ask more info about that function specifically. And we'll know here other ways that we can use it. So here you can find more names, examples of, or you can keep trying different ones and see which one you like. Allison Horse has a cool image that I found it very cute of examples of the different formats. So this is a screaming snake case that will make your entire titles uppercase. There's a stop case, snake case, camel case. So there's a couple of different formats that you would like to use, which is very, very helpful. Again, find a format that you like, stick with it, and be consistent. Just gonna save everything I've been doing so far. Okay, so now I'm gonna show you about this very cool function called separate and unite with a different data frame. So I'm gonna create a different data frame. I'm gonna call it DF, mainly because I just wanna show you what it does. So if I look at this data set I just created, it's just one column. I called it X, and the content is A period B, A period D, B period C. Just that's what I got. That's my data set. So I can use the function separate here. So and I can tell it to the column that is called X. So I call my data frame DF. Then I'm telling you to use the function separate. And I want to separate the column called X into two columns, column with A and column with B. Those are just random names I gave it. So if I run it, now I'm going to end up with two columns, column with A and column with B. And they're going to be, what it does is separates it using identifying any non-alphanumeric value in that specific column. So if I had put dashes, periods, it will find out non-alphanumeric value, and then it will assign them like, okay, so whatever happened before that period must be part of the column one. Everything that happens after that one period must be column two, and so you can do that. So you right now what I did is separated them. So now they're in two separate columns. Cool. Now I can use this data set for whatever I want to. Sometimes I don't want both. I just want the second variable, whatever is after that period. That's all I want. So instead of calling it something, you can just click NA or call it NA without a quotation mark. And then here I'm telling it, just give me the second column and call it B. So when I run it, it's just going to give me the information and call it B. You can also use separate. Oh, this is what I wanted to show. So sometimes you have columns that the content have some NA. So you may be worried what's going to happen with those. So let's create a new data frame and let's look at it. So in this example, I have spaces as my separators, and then row number 4 doesn't have any content, so it's an NA. So if I use separate in this data frame, and I'm telling it to give me 2 columns out of column F, when I run it, it gave me 2 columns with A's and columns with B's, because that's what I called it. And then A is in 1 column. And I don't know if you remember what it looks like. Let's run it again. So in this example, row 1 has only 1 value inside of that cell. Row 2 has A and B, row 3 has A, B, C, and then row 4 has an A. So when I run separate with that specific data frame, and I'm telling it, just give me these 2 and call it this name, I get an A because that's the 1 value that it found. And then there's nothing else. And then there's AB and AB, and it didn't give me the C because I didn't ask for that third column. And the last row has an A for all of them because it didn't have any content. So it won't break it. That's mainly what my example is, what I wanted to show you is that if you have an A in there, it won't break it if you just separate in there. It will tell you that there's nothing in there, which is very cool. You can use also unite to do the opposite. So for example, if I have run everything that you just saw here, so if this is what we've gotten, I can use unite, tell it what my new column is going to be called, and then I told it that I want to unite columns 1 and 2. And then it's going to unite it. And the default is an underscore, but you can specify whatever you want to. You can, let's search how to do that. Yeah, so you can use step and specify anything that you want. So if I wanted to, I could have made a percentage. Why not? Makes no sense. Probably shouldn't do that, but I could if I wanted to. So that you can specify whatever you want to. If I want to, I can just leave it in a space, and that will have created what we did at the beginning. That's very cool. But something that you have to remember is that when you do unite, it will create like a new united as a character. So my NAs that were before that were blank, now actually are called na. So it made it a character. So just remember that. Are there questions in there? Or should I not worry about it? Okay, cool.
I think you're good. I think we've been answering all the questions. So
thank you. Thank you so much. Because I completely ignored that, and then I saw 20 something and then like,
yeah, you're good.
Thank you. Okay, so that's pretty much like changing your title names and how you can modify them and make it so they're all like the same and consistent. So now let's go back to our actual data set and doing some data manipulation, wrangling for the content, not just the title name or the heading name. So first, let's learn a little bit on how you can select a specific columns on your data frame. So sometimes you get data frames that have hundreds of columns, and you don't need hundreds of them. You just need a certain range. You can extract those columns out by using the function select. And like it then says, you will select the variables or columns from a larger data frame that you want. So for in our data frame, in our original data frame from this one, we have 23 variables. So we have a lot of columns, but we don't want to select all of them. In this case, someone needed this data frame. They just needed me to give them the gestation column. So what I'm going to do is I'm going to call my data frame. And then I'm gonna tell it to, sorry, I'm trying to delete it. So I'm calling my data frame that I originally called it data. Then I'm gonna ask it to select only the column called gestation. I don't even have to put in between quotation marks. So what that's gonna do is simply give me the column gestation. It took it out of my big data frame, and now we only have one of them. You can also select a range of columns. So instead of labeling each one of them, you can just specify a range. So in my example, what if we wanted all the variables that belong to the father? And like I mentioned earlier, all the that variables have a D in front of them. So if we look at our data set again, will be all that starting here in the array and ended in DWT. So we only have 5 columns that are coming from the data info. So in that case, I can call my data frame, then select this specific range. So I want it to start at the array and end at DWT. By doing that, it will only give me the 5 columns I have. And that way we can extract them. I can also ask to give me certain columns, not necessarily that are together. So for example, if I wanted the ID column, so the first column in our data frame. So if I wanted this ID column, and I wanted then everything after the father information, we need to look here. Where is the end here? So I don't want anything in between ID and marital. And then I want everything else all the way to the end. I could specify by saying, okay, let's call my data frame. Then let's select the columns I want. So I would like the column ID, and I want this range. I want this range to start in marital and end in the last column of my data frame. This is a cool function here that will allow me to use without specifying the name, because sometimes it's a lot easier to just give me everything all the way to the end. So if we run that, we should only have the ID column and marital and everything after marital. And that's what we got. This is very helpful, but you don't only have to select. Sometimes you just want everything except for that one variable, except for a range of variables. So instead of using another function, all you do is add a minus and then the name of your variable. So in this case, if I wanted all the columns in my data frame minus the data frame that is called marital, then I will say, let's call my data frame, then select everything minus marital. So if I run it, now you shouldn't be able to see it in here because we took it out. So we unselected them. So that's mainly with select. The filter now, instead of selecting rows or columns like we did before, we're technically selecting or filtering rows in my data frame. So in this case, filter will allow us to choose a subset of cases based on specific conditionals if you want. So, okay.
All good.
I'm good. I thought with me, everything's like, oh, I'm alone. All right. So let's use filter in this example to keep only the rows or the data from parents that have never been married. In our data frame, the married information will be the value number 5 in the column marital. And we know this because we look at the dictionary, and the dictionary tells us that every 5 that we see in this variable means that they have never been married. So, and then we're going to use select to only give us a specific column. So let's forget about the select section for a little bit. So we call our data frame, and when we tell it to filter all the rows that marital equals to 5. So what that's going to give us is only the rows, in this case, there were only 6, but it will give us only the rows where marital equals 5. And I could have done the same for 3 if I wanted to. And there are 5 people that have 3 as marital. So that's just like the horizontal selection of rows. Before we learn, we select the vertical of the column selection. And you can add many more conditionals. So if I wanted, like, I want all the maritals to have 3, but they're also smoke equals whatever above the aces or whatever. So we're going to go a little bit more complex of those conditionals in a little bit. But let's finish what I wanted the example to be. So then I want to use select to only show us the column age. So by doing this, we'll know the age of all the moms that have never been married, the age that they delivered. So these were the ages of all the moms that have never been married in our data set, because that's the filter we gave at the beginning. Something to remember with filter, we're telling it what rows we want to keep. We're not filtering things out. I don't know if that makes sense. We want to filter things that we're going to keep. So in this case, I want to filter and keep all the maritals that are equal to 3. This 3 is not never married. Okay. So you can also do the opposite. You can keep only those who are not divorced. So that's instead of using equal, now we do the equal, not equal. So we use filter, we call our data frame, then we use filter and we tell it to keep all the rows that marital does not equal 3. And that will give us all the other rows that do not equal 3. So if we go to marital, you should never find a 3 in there. If you did, something is wrong. Maybe it's a character and it had an extra space, but your filter should have kept everything that is not a 3 in your marital column. You can also use this very cool thing here, percent in within your filter function in order to keep only those that meet a specific range or that equal whatever is in a specific range. So in this case, if I wanted to filter all the rows of people that the marital value was 2, 3, or 4, 2, 3, or 4, then I could say, let's call my data frame, then use filter. So we want to keep all the rows that the marital value is in this specific range. So 2, 3, or 4. So if we call it here and we look at the marital column, we should only see 2, 3, and 4 values here, nothing else. So it's kind of like, if this value is in this basket of values I'm telling you, keep them. So that's pretty much what we're doing with the percent in percent. You can create a chain that keeps only like multiple conditions, like I was mentioning earlier. So in this case, I could only keep the rows of the moms that have an education level of 5 and whose age is in this specific range. So we're going to filter now our data frame to only keep the moms that have an education level of 5, which in our dictionary tells us that those are the college grads. And we want to also only keep those that meet this age criteria. So that are between 20 to 30 years old. When we do this filter, there is 144 of those moms. And if we go to age over here, you see that they meet our criteria that are between That's without age. Yes, they're between 20 and 30. So you could apply multiple conditions in there, not just one. So you can just specify multiple at a time. You just add another comma, and I could have added something else. So I want their height to equal, no, to be more than 65, I know. And that will give me 55 rows of moms that were college grads, that were also in the range of 20 to 30 years old, and their height is more than 65. I don't know what 65 stands for, but they're more than that. So these are all the different symbols that you can use for like more than, less than, more, equal than, for any of these conditions I used in before. We mainly use the equals and the not equals in my examples, but you can use all these other ones. Okay. So there are some exercises that you can complete in the examples over here for select and filter that you can do. And I'm gonna walk you through where those are very quickly, so you can do them on your own or right after this talk. So you're gonna go to the exercise one. So right now I'm walking you through the examples. So you can go to the exercise one. I'm just gonna open the document. And you're gonna see many code chunks that are blank just because I left them for you to complete. And here are some instructions on how you should do them, or what I'm asking you to do. There are a couple that you can do many different ways, and there's like coding. There's many different ways that you can solve the same problem. Some more simple than others. So in some instances, I'm gonna ask you to do like different options that you can show me. But there's solutions over here in the data manipulation solution. All right, I'm not gonna open it so you don't see the answers, but they're there if you need to. Okay, let's go back. Okay, so for mutate now, mutate is a function that will help you make new variables or change existing ones. So sometimes you just want to create a new column based on other columns, or you just want to create a completely new column that has a specific value, or sometimes you want to modify the content of some columns for how many reasons. So let's walk you through these different scenarios of when you normally use mutate. So I could create a new variable with a specific value. So in our data frame, I told you that this data frame was collected in 1961 and 1962. Let's imagine that next month, we're going to be given a new data set that we're going to be asked to merge later on. So we know we're going to get this data from the 70s, and this data was from the 60s. To make it easier, you now create a new variable with the value 60. So whenever you merge the other data sets, you know that the other ones are the same. That's my imaginary world. So we're going to call data frame, like we call it data. And then we're going to use mutate to create a new column that we're going to call data underscore decade. Wow, forgot English. Decade. Data underscore decade. And I want the content for all the rows in that column to equal 60. So 60s. So what that's going to do, if I did it right, it's going to create a new column called data underscore decade. So if we go all the way to the end, that's what it did. It created a new column called data underscore decade, and all its rows all the way to the end have the value of 60 in there. So that's one way that you can use it. Very simple. Let's create one column with a specific value. Cool. You can create a new variable based on other variables. So for example, we can create a column right now. We have the weight and height of mom, dad, and the baby. Let's say that we're sharing our data frame with anyone outside of the US and the UK, and they need it in kilos. They don't need it in pounds anymore. So they need it in kilos. So I'm going to create a new column called WT_K. That's the new name of a new column I'm creating. I'm going to do a conversion. So I'm going to multiply by 0.454, which is apparently what 1 pound equals to in kilos. So I'm going to call my data frame. Then I'm going to mutate. So I'm going to create something new or modify something. So in this case, I'm going to create a new column called WT_K. And I want the content to equal the content of WT_1, which is the mom's weight, times 0.454. So if I run this and I go all the way to the end, I should be able to see my new column, WT_K, that has the weight of the mom in kilos. Sometimes that's too many decimals though. Let's figure out how we can round it and have it with less numbers. So you can use the function round inside your mutate function to tell it to whenever you make this calculation, I want you to round it by 2 decimals. So I want it to only show me 2 decimals. So when I run this and I see it all the way to the end, I should only see it with 2 decimals. And that's what we see. I could also specify and can only show me 1 because that's too many numbers. Let's go, and that's what happens. So this was done based on the information that we found in this column. So we totally used the information that was in another column to create another column using mutate. Like I mentioned earlier too, you can modify the columns that you already have in there. And how do you do that? Let's walk you through this function called case_when. Modified an existing variable. So for some reason, you want to have the real label in this example. You want to have the real label rather than the value. Let's say that marital 1, 2, 3, and 4, you no longer want them as numbers. You actually want them as their actual text value. So in this case, I'm going to use data. I'm going to call my data frame. Then I'm going to use the function mutate. And inside of it, I'm telling it to, instead of create a new one, I want you to rewrite, like override the column marital that I had before and use case when. Case when is kind of like an if statement. So every case when marital equals 1, I want you to replace it with Mary. Every case when marital equals 2, and the tilde, I want you to replace it with legally separated. And the same for 3, 4, and 5. So I'm telling you specifically, if you find any of these values, I want you to replace them with these new values over here. So when we run them and we look at the column marital, we should no longer see numbers in there. We should see the text that we modify with case one. It just happened that we have many ones in here instead of the other ones. So that's how we can use case when in this situation. Sometimes we make mistakes. We want to fix that one situation. So for example, if I have this data frame, this is what we have before, and we go all the way to ID, and we realize that this first row here we called it a family number 15, and it turned out that we made a mistake and it was supposed to be a family called 19. So to fix this, we can say, okay, let's mutate the column ID. And if you find a case that equals 15 in the ID column, so that specific one over there that we're targeting, I want you to replace it with 19. If you find anything that is not 15, which is mainly what this will mean, I just want you to keep whatever value was in ID. So when you run it, you should be able to see that that one that we found was changed to 19, and every other one kept its ID original value. So we can do that with multiple things, things that you want to change in a way that you automatize it. So instead of changing it manually, now you have in your code. So if someone shares with you this data frame again with the same mistake, you already have the solution as part of your code. Let's try to minimize the amount of changes that you do by hand if you can incorporate it in the code. All right, so if you want to use summarize to create, if you want to create means and standard deviations, minimum and max, like this descriptive analysis of your data set, like very quick ones, you can use this function called summarize or summarize. It goes with Z and it goes with S. It works with either one. I go back and forth. I guess I use the Z in here. But both of them work. So with summarize, as the name implies, you will get a summary of your data set. So you will just shrink your data set into the summary that you'll ask it to give you. So for our data set that has weight, gestation, and height, and all of this information, let's get the mean days of gestation for this sample. So we want to know what was the average amount of days of our sample of moms that are in our sample, the average days of gestation for this mom. So what we're going to do is that we're going to call our data frame. Then we're telling it to summarize our data frame. And how? By creating a new column. I call the gestation length mean, so you can call it whatever you want to. And I'm telling it to give us the mean, and you know what the round is. I'm just telling it to round by 2 decimals for just example. But I'm telling it to give me the mean of the column gestation. What is this, you may be wondering? I'm telling it that if at any point in my data frame in the column gestation you find an NA, to remove it from the calculation. So I'm telling it to be true. Because if you don't do that and your data frame, that specific column that you want to mean from, and it has an NA in there, it will give you an error because it cannot calculate an average of a range that has an NA as a value. Why is the default NA not NA removed false? It's annoying. I never want to not remove an NA, but I guess it's one way for you to figure out that, or to find out that you have an NA in that column. Like, I guess it can be helpful, but I never really want that. So I always keep my NA removed true here. So what that's going to give me is a new column, gestation length mean, and my average. So this is the average days of gestation for the sample that we have right now, 279.34. And 0.34 because I told it to round it to only 2 decimals. That's one quick summary. Something extra that I wanted to show you that sometimes so like you see here, it's a table. So if we save this as a data frame, it would be still a table. Sometimes you just need the values so you can make other calculations later on. So whenever you want to do that extra step, you can use the function pool. And what that's going to do is going to change that one value into an object So now you can refer to whatever you call it, then as an object rather than a table. That's a very quick thing, extra thing I wanted to show you if you sometimes need this. But otherwise, you will have it as a table like in here. And then if you do this, you will have to refer to row 1, column 1. So sometimes doing this is easier. Okay. We can have multiple arguments in each usage of summarize. So we can calculate mean, means, maximum, standard deviation all in one chunk very quickly. So in the example earlier where we calculated the mean gestation length of the days of gestation, you can also calculate the minimum and maximum for this same variable. So what I'm doing is I'm just telling it to, these are the names I want them to be labeled that way. So you can create whatever label you want for each of those columns. But I want these to calculate the mean. I want these to calculate the minimum. And I want this to calculate the max of this one column called gestation. And if I run it, you should see the 3 columns, mean, gestation, minimum, and max. So you already have that information.
Hey, Joscelin?
Yes.
Sorry, I didn't mean to interrupt you. Do you want to take a 5-minute break so you can take a breather, and then if anybody has questions, that way we can give people time to think of questions if they have any. But yeah, that way you can get a drink and take a breather real quick.
No, that was good because that's why I put this question mark in there.
Oh, you wow.
Perfect.
Yeah,
that worked out. Yes, you can definitely take a 5 minutes.
Yeah, I'll pause this real quick. Okay.
Cool. All right. Any other questions? Nothing?
I think we're good for now.
Awesome. So we just finished how to do some calculations on mean, max, standard deviation that you can do with summarize. Sometimes you want all these calculations, but grouped by certain category. So in those situations, we can use group by. So what that's going to do, I love this little art. It's so sad. Group by allows us to perform calculations in each of our groups. So we just specify which groups we would like. So in this case, I wanted to calculate the mean gestation length like we did earlier using summarize. But I wanted to do it by grouping it by the smoke habit. So smoke habits have multiple values in there. So for each of those values, I want to know what the mean gestation is for my sample. So 0 was moms that never smoke. 1 were moms that smoke now, so when they deliver the baby. And 2 is that they smoke until they got pregnant. And then 3 is that they used to smoke, but they no longer do. So we have 0, 1, 2, 3 in our data set. So I want to know what the mean gestation length is for each of these groups of moms. So using group by and summarize, I will be able to get crazy. The mean gestation length for moms who never smoke, mean gestation length for moms who smoke now, and so on. You can see that it also calculated a mean gestation length for the moms who didn't give us any information about the smoking habit. You can get rid of that row if you want to by using drop NA function before you do the grouping by. So what that's going to do is going to drop the NA the NA values of the group of smoke. So in the variable smoke, if you find an NA, it's just going to get rid of it. So whenever you calculate the summarize, after you drop the NA for that column, we shouldn't see it anymore as a possible group. So that's very helpful for sometimes when you're writing reports or sharing information, to just have the the calculation given to you by all these different groups. We can use group by with multiple groups as well. So it's not just one variable that we can call it. We can tell it that, okay, give me the mean gestation for all these different groups of moms that have different smoking habits, and by all these different education levels of all these moms. So if we add this one more column here, then we should see that it will calculate the mean gestation length. As you can see, all of these are moms who've never smoked, but specifically, from the moms who've never smoked, these are the ones that had a school degree, I think, from 8th grade to 12th. And so on, like for the different education level values that we have. So all of these are for the moms who've never smoked. All the ones are for the moms who smoke now when they deliver the baby. And by education level. So you can add even more groups if you wanted to. It just gets more complicated to explain what they are after you use so many of them. But it can be very helpful if they don't have too many values like education. Each one of them has 7. The order that you see these things is the order that you list them here. So if, for example, I wanted the other way. So it's easier for me to read it to my coworker when I'm giving this report very quickly. I would say, oh yeah, the mean gestation for the moms who did not finish high school that never smoked is this. Very quickly. But that's just by reorganizing how I wanted to show me my mean gestation length by grouping. So you can totally change the order if you wanted to. And again, we could have added more different values or calculations here if we wanted to. A cool thing that I learned way too late after I started learning R was the across function. And you can use it within the mutate or the summarize function. And what it does is like applies a specific function to a selection of columns. So I could tell it to calculate the mean for all of this range of columns. And that would have made my life so much easier a lot earlier, but at least I found it later on. So in our example above, we calculated the mean for gestation. But what about if we wanted the mean for gestation and also the mom's age, the mean of mom's age, and also the average or mean of the dad's age? So what if I wanted the mean for all these 3 different variables? Instead of going one by one as we were doing it earlier, I can forget about it. That's not what it's telling me. We can tell it that this is what we would have done earlier if I hadn't shown you about across, but this is what I would have normally have done. Do each column for each of my variables and then call it age, mean that age. But now that we know better, I'm using across, I can use summarize as we usually did, then tell it, I want you to summarize my data frame, calculate the mean, as we say here, across all these 3 different columns. So I listed in C and parentheses all the columns across all the columns that I want them to see to calculate a mean score for. So if I run this, it will give me the mean for the gestation column, the age column, and the dad's age column. This is the mom's age and this is the dad's age. I say in here that I want you to give me the mean based on this grouping, based on the smoke habits. And this is why we see 4 different rows in here, because it's giving me the mean gestation length for the moms who've never smoked, the average age of the moms who've never smoked, and the average age of that whose partner never smoked. And it is just Very simple. In one line of code, we calculate the mean for all of different variables across all of different variables based on a grouping criteria. Amazing. I love it. Once we have our data frame, we can create a new data frame by assigning it a new name. So I can make these modifications. And this is exactly what we created a little bit earlier. And I'm telling it to, from now on, this is a new data frame, and I want you to call it 2_graph. I wanted to use the data frame to graph it. So you see, it created a new data frame here with all the manipulations I just happened to do. I'm gonna see what it looks like. And it's that's my new data frame. I created a new data frame, and this is the one I'm gonna share as a CSV or share it with other people or use it to graph, whatever. You can do a couple things though before you do that. So you see the order, we have the smoke, gestation, age, on that age in here. We can relocate and we can move columns around to make your life sometimes a little bit easier. So sometimes you want to force a CSV and then you don't really like the order of the columns, even though you did at the beginning, or there's just so many columns in there sometimes. So you can relocate it and move them around without you having to go back to previous codes and modify the order. So let's take the 2_graph data frame that we just created. Let's move the age column before the gestation column. Now I like using relocate because it's very intuitive. So what I'm doing here is I'm calling my new data frame called 2_graph. Then I'm telling it to relocate which column, the age column, and I wanted it to position before the column called gestation. So right now it's smoke, gestation, age, and that age. So if I run the relocate function, yes. Now it's smoke, age, gestation, that age. So it did what I told it to do, and it moved the column age before the column gestation. And you can also specify it to go after. So what if I want gestation to be the last column? So I can call my data frame, then tell it to relocate the column gestation and to position it after the last column. Whatever is the last column in my data frame, I want gestation to be after that last column. When you do that, gestation is at the very end. Okay, now I like it. This is perfect. This is exactly what I wanted in the first place. So now I did an extra step, which didn't have to, but I created another data frame called CSV to export. You can create as many as you want. It just needs to make sense to you and everyone else who uses code. But I created another CSV to export with the right order of the data frame I wanted, because I wanted to export it as a CSV. So I imported it as a CSV and I want to export it as a CSV. So I'm going to use the function write_CSV in this case. And I'm telling it that I want you to write a CSV using this data frame. And I want you to call it or position it here. So I told it to go to export folder and to create a new CSV called example to export. So it said it did it, but let's check it out. So we go to our export folder, and here it is. We just created this example to export file. Export them with it. Okay, so now we have pivot longer and pivot wider. It used to be called something different. Now it makes more sense. The names make way more sense. So what it does with pivot longer is like it will make your wide data set longer. It will just transpose them. The pivot wider will do the opposite. If it has a long data set, it will just convert it into a wide data set. So remember our data frame CSV to export? It looks like this. So we have 4 columns separated like each row for each small group. Let's use pivot longer for this data set. And I'm telling it that I want you to pivot longer the columns age and dad's age. So the mom's age and dad's age, move them in a longer format into a new column that now I'm gonna call it mom and dad. And I want the values of those 2 columns to be in a new column called age_mean. What that's gonna do, I don't want to assign it to oops yet. Is it transposes previous columns. Remember we had a age, a column for mom's age, a column for dad's age. Instead, now we have 1 column for age, average, with mom and dad, the columns that were separated before, now they're together in one column only. So now we know this is for mom and this is for dad. And then we can use mutate and change that. Or we could have changed the name of our variables before we did the pivoting. So it would be mom and dad, and it would be a lot easier for us to understand what they were. But that's the basic concept of what pivoting is doing to your data set. And you see that the value of the columns that you didn't do any modification or any transposing, it stays the same, like the station. So what if you have gotten a data set like this originally? And you did not want that. You wanted a column with the age mean for mom and another one for dad. So let's imagine that happened. And I'm going to create a new data frame just for the example. I'm going to call it oops. Since I ran out of creativity when I was doing this, so I just call it oops. And I'm going to tell it that pivot wider. We're going to pivot wider our data frame. So if you look at oops, which is the one we just created, it looks like this. But I want these wide data sets to now look longer, like we originally had it. So what we're going to do is that it's going to create columns that are going to come from the column called mom_dad. And the values of those 2 new columns that were, or in this case 2 new columns, are going to come from the column age_mean. And when we do that, it's going to create what we originally had. So it created a column for each of the values that were mom and dad. In our example, there were only 2 values in there that were distinct, age and DH. If we had had another one, like grandparent age, inside of that column, it would have created 3 columns. So it's based on the values that were inside of the column we specify here in mom_dad. And the values that were inside of these new columns came from the age_mean column that we had originally. And now we're back to where we started to move it to the now wider format. Sometimes it's helpful for graphing, sometimes it isn't. Usually when the tidy format, you want it longer. It's easier for ggplot and coloring. But sometimes this is necessary for reporting or sharing with other people. So that's mainly all the content. And I have an exercise that if you would like, you could do with me, or we can have like 10 minutes that you can try to do it. And then we can go over it, and then it's pretty much all I'm going to talk about. I'm going to share a couple more resources when we're back. But this is a big exercise. So remember, you have the same data frame that I share with you. You have the same data frame. So I want you to create a new data frame. And I want you to do a couple manipulations before you create a new frame. I want you to use filter to only include those that have an age younger than 30. I want you to use mutate to transport the gestation variable in 2 weeks rather than days. Then I want you to use group by to create modification groups. And based on those groups, I want you to calculate a new variable called mean gestation week. All of that in one code chunk. And then, of course, make sure to export it as a CSV. We can spend like 10 minutes on that. Would that be good?
Yeah, that works. If you're okay with sticking around.
Yeah, no, yeah.
If anyone has any questions, feel free to let us know. But yeah, if you want to stick around and do the exercise, we can give it 10 minutes and then circle back. Yes, we will be sharing the recording. It'll be posted on YouTube in the next couple of days, probably.
You know what? Before I do the exercise, maybe I'm going to do the show resources and then the exercise for people that don't want to do the exercise. You can just go ahead and if you want. But before the exercise, let's quickly go through my thank you slide. Of course, when it comes back. So thank you so much for listening to me rambling about these different functions, the exercises. Now what? Like now you know some functions, and you're gonna be listening to more Our Ladies talks, not only here but in other like sometimes different countries, different continents. It's very cool. It's a very cool network. But a cool place that people share a lot of resources and a lot of free resources. It's Twitter. Out of all places, I was very surprised that it was Twitter, the platform. But there is a cool number of people that you can follow, and then they regularly share codes, resources, classes, paid or non-paid classes that you can take, solutions to problems. Something I love in the art community is they're very willing to help you out, no matter your level of art. They're just the nicest people ever. I was introduced to coding through Python. So Python was my first language that I learned. But the community felt too mean to me as a woman and a woman of color. That it was, every time I had a question, I was like, oh my gosh, you don't know that? Well, no, I don't. I'm new at this. I need help. I need you to hold my hand for a little bit. I don't know what you're talking about. But they would shame me before giving me the answer. And the art community does not do that. And I love it. Because regardless of your level, they're like willing to help you and not feel you bad for not knowing. And I truly love this community. These are very cool people that you can follow and learn more from them, what they're doing. There are a couple of resources. I do have a GitHub wiki where I spend way too much time on Twitter. So every time I find something very cool, I add them there. And I have like hundreds of resources that are mainly free. I don't think I add anything that's not free. Where you can learn more about art if you're new, and also like if you want to learn new cool things. Like I learned how to make my computer talk to me every time it's finished doing an art script. It scares the hell out of me every time it finishes. But it's very cool to tell me like, hey, Joscelin, your code finished running, which is fun. You can also visit the Art Studio site where you can learn more, and they have different levels in there, which is very cool. I just want to give a shout out to visit Crystal Lewis wiki. All these different like data wrangling functions that you can look at. That's very cool. It's a nice like cheat sheet that you can go back to every time. Have fun. I truly recommend having fun. It may be frustrating at first, but it gets a lot better. You're gonna get frustrated with your code that you write like even days before that you learn something cool. Like I'm frustrated with past Joscelin from last week for writing a code, and now I know better. And that happens. It's part of the process. You're always learning. There's always something new to learn. It's very cool. Remember that there is an entire community happy very happy to help you out whenever you encounter any obstacles in your learning path, and they're very happy to hype you up too to continue this journey. So don't forget, we're there for you. That's mainly it. So thank you so much, and all of you have access to this GitHub and other resources, but we can go back to the exercise. You can finish that, and you have access to the exercises too, so you can do them on your own time, anytime, and look at the solutions if you want to check your work. That's pretty much it. Bring you back to the exercise, and you can stay and finish it with me, or thank you so much for coming.
Thank you, Joscelin. Yeah, should we just stick around for a few minutes and just see if anybody wants to try it, and then we can wrap it up? Sound great? This has been great, Joscelin. It's awesome. I appreciate it. I appreciate you being here. It was nice to see you again. I will, and you know what, and I'll probably just go ahead and stop the recording so that people can ask questions about the exercise. But yes, thank you so much.